Um, okay, this is one of those piecewise functions, and oh, all right. Let's see. How do I want to explain this? Mhm. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's good enough. Okay. 1, 2, 3, 4, 5. All right. If I were to graph this function, this is a linear function. It says 3 minus x, but that's the same as negative x plus 3, and that puts it in the mx plus b equation form. So it's a linear function. It crosses the y-axis at 3, and it has a slope of negative 1, which means it goes down 1 and over 1, down 1 and over 1, down 1 and over 1, and down 1. Need some more lines down here. Oops. Switch to black, please. 1, 2, 3. Okay. And then down 1 and over 1. Down. Okay, and we stop right there. This is all I have of this line, because it wants it to be x is less than 4. So technically that's an open circle, because right here this is 4 on the x-axis. Then it says that, remember, this is y. Y will equal just x at x equals 4. So 1, 2, 3, 4. There's a point right there. That's it. That's the only point for that function. Y equals x just at x is equal to 4. And then, need another color. Let's go with green. This one, okay. 3x squared, that's a quadratic, but they only want x's greater than 4. If I put in 4, 4 squared is 16, and 3 times, oh good God, 3 times 6, that's 48. My graph here only went up to 20. So let's pretend that right here is 48. So now you have at x is 4, you have an open circle there. And then if x is 5, good God, that's 3 times 25, that's 75. That is way up here somewhere. So yeah, that's our function. It's a piecewise function. It's a linear function in the red. It's a quadratic in the green, but only that part of the quadratic. And then you have this lone dot in the blue. And so you can see it says determine why the function, all that mess, is discontinuous at a given point x equals 4 on a graph. Well, you can see there's a big gap here. It jumps from here to here to here. So when you're filling out this part, there's a drop down box, and your choices are an asymptote, a removable discontinuity, or it's a jump discontinuity. And then it says the function is discontinuous at 4 because, and then they give you those 3 conditions about the limit of a function. And on this one, it will fail because condition 2, the limit as x approaches a of f of x actually exists at a. That's what that is right there, that point. I hope that made sense.